This is for worksheet 20, elc138, worksheet 6. Now I'm giving you this circuit, and if you had drawn it out, this is what you should have come up with. Something equivalent. May not look exactly like this, but it's definitely equivalent. And so the first part, I want you to do a Thevenin analysis studying the 5K. And what we mean when we say in Thevenin we're studying a resistor is what we want to do is take this whole circuit and reduce it to a Thevenin circuit. And if you remember from the last video what a Thevenin circuit looked like, you should. We basically are going to boil this down to a power supply and a series resistor. And that's going to be our Thevenin circuit, but it needs to be the equivalent Thevenin circuit of this circuit. And so there's a method for doing that. And there's also a method for doing a Norton circuit, and I want to do the Norton circuit of the 3K. So it's not a matter of find your Thevenin circuit, convert it to Norton. It's Thevenin of the 5K, Norton of the 3K. And you'll see that each resistor has a different either Thevenin or Norton circuit depending on how you want to do it. So the first step is remove the resistor you want to study if you're going to do Thevenin analysis. So I'm going to cut my 5K out, and I have a gap there. And if I labeled the gap A and B, which I think I can do. So let's make this point A and this point B. Oops. Okay. Then your Thevenin voltage for your Thevenin circuit would be the voltage you measure in this condition between A and B. So from a circuit analysis standpoint, if you did the circuit analysis on this circuit, whatever you would get for a voltage measured between A and B would be your Thevenin voltage. So if I look at that, then what I have now is without the 5K resistor, I only have one current path. I have a current path around the outside of this circuit. I have no current through the 3K because this is open. So if I have no current through the 3K, Ohm's law tells me that my voltage drop across my 3K is 0. So basically I need the voltage between this side of the 6K and this side of the 6K of a simple series circuit. That will be my Thevenin voltage. Once I have my Thevenin voltage, then I need my Thevenin resistance. And so to get my Thevenin resistance, I want to go from A to B and figure up the equivalent resistance for this entire circuit. So as we talked about in one of the videos, whenever I'm going to do a resistance substitution, I'm going to remove my voltage source and replace it with a short. So now if I go from A around to B, I can go either through a 2K around to this point, or I can go through a 6K around to this point. So your 2K and your 6K are in parallel. And then those two resistors, whatever they are in parallel, are in series with a 3K resistor, such that the resistance from A to B becomes my Thevenin resistance. Now, if you figured out the voltage drop across your 6K, and then you figured out what a 2K in parallel with a 6K is, and then in series with a 3K, you've got your V Thevenin and your R Thevenin, and you can do a Thevenin circuit. If you wanted to create a Norton circuit out of that, then you take your V Thevenin divided by your R Thevenin, and you would get your I Norton. So you could do a Norton circuit, and your V Thevenin will equal your R Thevenin. wait, your R Thevenin will equal your R Norton, if I say it correctly. So that would be the Thevenin circuit I asked for. Now the other one I asked for is a Norton circuit, and I don't know how many times I can undo. I should have thought about that. So if I do F9, what happens? F9, oh yeah. So I undo back to my original circuit, and now what we're going to do is Norton analysis. So for Norton analysis, what we're going to do is we're going to cut out the resistor again, and we're going to relabel it A and B. And you don't have to label it. I'm just trying to do this to demonstrate the process. So hopefully you get a little better visual of what we're doing. And I'm sure he does a great job in the book. Okay, so I've got my A and B again. Now to do Norton analysis, what I want to do is I want to put a short or a wire between A and B. And I want to find the current that flows in that wire. When I find the current that would flow A to B in the circuit you see now, without that resistor, if there was a wire between A and B, that would be my I Norton for my Norton circuit. So, what's easier? Finding the voltage drop across the open and coming up with the Thevenin circuit and then converting it to the Norton, or coming up with the current through the short and determining what the I Norton is and then coming up with the Norton circuit. So the reason there's Thevenin and Norton is you can sort of go both ways and then convert, whatever one's easier. You really won't know which one's easier until you gain some experience working with circuits. But you could come up with the current A to B, and you could even do it in Spice. You could just make the connection, figure out what the current through the 5K resistor is, and then that 5K current would be your Norton current, if you would. Okay, so you got to come up with a Norton current. So if I short this, then I've got a 2K feeding into a 5K, 6K. They're in parallel, so the current's going to split. I got to figure out what this current is. If I know what that current is, I have my I Norton for my Norton circuit. The other thing, and this is going to look very familiar, is I need my resistance from A to B to come up with my I Norton. I mean my R Norton. And so just like we did in the last problem with the Thevenin, I've got to go from A back around to B. Okay? And if I can come up with that resistance, reducing all the resistances in the circuit to 1, that will be my R Norton. It's also my R Thevenin, because R Thevenin and R Norton are equal. So if you can find one, you can find the other. This is a different value than the Thevenin problem because I have different resistors. So now we're going through the 5K, and then we're splitting to a 2 and a 6 in parallel. So it's a little bit different calculation. Again, to calculate the resistance, I'm going to short out a voltage source, pretend it's not there. It's just a wire. If a voltage source was a current source, then I would open it and I would leave the open, and coming up with either R Norton or R Thevenin. Okay? So once you have the I Norton, R Norton values, you can just draw the circuit like you've seen before. And that will be for the 3K resistor. Thevenin and Norton were tools to come up with all the possible combinations, because basically it gives you the open voltage if a part opens, and it gives you the short circuit current if a part closes, because the voltage drop will go to 0. And then as you put in different values between A and B, other than say the 3K, you can figure out how that will change your circuit if you put in the 3K, or how that circuit would work if you change the resistors, because now you've got a much simpler circuit to work with. And that's why it was developed. Now we got all this software. If you want to change the 3K to a 4K, you just change it to 4K, rerun your simulation, and you can know how it's going to behave. So anyway, that's Thev Norton. It's a good exercise for circuit analysis. It's a little more fun than just rerunning and rerunning and rerunning over and over, and you can see what has happened. Anyway, I thank you for watching, and of course you could dot op these and just go, but hopefully you work it out manually. If you don't, you can always hopefully you're getting good enough with LT Spice, you can figure out how to do it this way. Anyway, thanks for watching and good luck, and this should be everything you need to complete Worksheet 20. Good day.